I would not. I suggest you wait to put your axes scale down until you have your points. Because sometimes you just immediately start putting your scale down and it's not going to match up with what your points are. But once at this point, I think you go ahead and go every pi over 2. And so I would start at 0 here. And so that's 0, and that's negative pi over 2. Negative pi. Negative 3 pi over 2 and negative 2 pi. And so I'm going to plot the asymptotes. And what were our points? Negative 3 pi over 2, negative 2. And for the y-axis, if you don't mark anything, it's assumed to be 1. Okay, so if you're going to change it to, either maybe spread it out or shrink it a little bit just to fit on there, make sure you mark your y-axis. If there's nothing shown, we'll assume it's 1. And so we got negative 3 pi over 2, negative 2. Negative pi 0, negative pi over 2, 2. And it goes from low to high, and it is a curve. Don't try and make this like a straight line, a diagonal line. Make sure it's a curve. And it'll eventually work its way towards the asymptotes as it gets further up and further down. Now the directions, I know it's not written on yours, but you gotta make sure you get this down. It says graph it over a 2-period interval. Well, what does that mean? 2-period interval means you want 2 branches. And you can either move to the right or to the left. I don't need the points again, but I do need that second branch. And obviously for this one, it'd be easier if we move it to the right. So I get, again, pi over 2, pi, 3 pi over 2, 2 pi. So that means I'll get another asymptote all the way over at 2 pi. And, hold on, here. And then just, like I said, just transfer the points over. And so it's going to start at negative 2, 0, halfway between, and then 3/4, 2. And then you'll get your second branch. You can graph this to see if you're right. You can plot that on your calculator, and you change it to radians, and just double check it as you go through there. All right, let's take a look at this next one. Go ahead and write that one down. Now notice it's cotangent. All right, we want a 2-period interval again. So we're going to have 2 branches. All right, to know what the cotangent looks like, you might want to go back. And your asymptotes are going to be at different places. They're not at negative pi over 2 and pi over 2. They're negative pi, 0, and pi are the 3 closest there to the middle. And we're going to work with 0 and pi right here. We're just basically going to work with this first branch. Now, all right, what do we got for, what do we got on here? Vertical stretch. All right, so take a look at that. Ian Kelsey, what would be my vertical stretch?
3.
Yes, 3. It's that constant out in front. How do I find the period, Connor?
Pi over b.
And what's my b value?
2.
Good. So my period is pi over 2. That means between asymptotes, you have pi over 2. And Mason, what do I get for phase shift?
Right pi over 2.
Okay, good. Right pi over 2. So phase shift. I'll just put plus pi over 2. All right, locate 2 adjacent asymptotes. So I need to locate 2 adjacent asymptotes. And all right, so you can remember what the heck to do. How do we do that? I know from yesterday, see if you can like kind of use what we did yesterday. I'd wait before you write anything down in case you, not that anybody would make any mistakes in here. All right, but it could happen. All right, Lizzie, you got any idea how to find two adjacent asymptotes?
Set 2x minus pi over 2 equal to the two original asymptotes.
All right, yes, exactly. So take that. Now, what are the two original asymptotes for cotangent? Okay, let's use 0 and then just stick with the positive 1, 2. So let's set it equal to 0 and then set it equal to pi. Okay, I'm not sure what I just said. I don't think I said pi. Okay, set it equal to 0 and set it equal to pi. All right, so and I'm going to put this in parentheses. I'm going to just say for cotangent, we want to use 0 and pi to set them equal to. So you're going to take 2 times x minus pi over 2 equal to 0. That'll be the first one. And the second one will be 2 times x minus pi over 2 equal to pi. So basically when we solve for x, it'll tell you where you move to. Okay, and then we'll go from there. Again, I'm going to tell you to hold off on doing anything with the graph till we get all the points, we get all the asymptotes. Well, on this one, I'd go ahead and divide by 2. X minus pi over 2 equals 0. Add pi over 2. So now we get it at pi over 2 is where that asymptote that was originally at 0 is. Divide by 2 over here. Add pi over 2. That gives me pi. All right, hopefully it makes sense since we said the period is pi over 2, that the distance between the first and the second one is pi over 2. If it's not, then you messed something up. You messed up the period, or you messed up figuring out what the asymptotes are. All right, so now you got asymptote number 1. First asymptote, which is x equals pi over 2. Then we're going to have 0.1. We're going to have 0.2. We're going to have 0.3. And then asymptote number 2, which is x equals pi for that. All right, so think about how you get those points. Okay, so set it equal to 0 and pi. That's one key part of the problem. This is another key part of the problem is how do I get those next set of points, okay, or each one. Dominic, you remember?
So you'll take the pi over 2 and then split it into 4.
And then where are we getting that pi over 2 from? Because I know my first asymptote's pi over 2, but that's not where we get it from. Where are we getting that pi over 2 from? Period. Good. So you take your period divided by 4. So period divided by 4 is pi over 2 divided by 4, which is pi over 8. And that's what we're going to add. So you're going to add pi over 8. And what is pi over 2 plus pi over 8? That is going to be 4 pi over 8 plus pi over 8, 5 pi over 8. Okay, do you know what the y coordinate will be?
Will it be 3?
Positive 3 or negative 3?
Positive.
Positive 3 because it goes from high to low. Okay, so it's going to be positive 3 because it's stretched by that 3 in front. So it stretches it up. So that would be correct. Add another pi over 8. And that's going to be 6 pi over 8, which is 3 pi over 4, 0. Add another pi over 8. And I get 7 pi over 8, negative 3. Okay, with what you have, for the grid, what would be a appropriate scale? You don't want to make it like too small, but you don't want to spread it out where it won't fit on there. So basically, if I just get pi, as long as I get that on the scale, I'm okay. And I think we can get away with going pi over 4. So I'd go pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, and then this will be pi. So pi over 2 and pi, I'm going to get rid of this here, are my asymptotes. And what did we say the first one was? 3, the y coordinate at 5 pi over 8. I'm going to just add a couple marks on my y-axis to go by 1 and fit in there a little bit nicer. I think yours would be fine. So I go 5 pi over 8, 3, 3 pi over 4, 0, and then 7 pi over 8, -3. Make sure you put arrows on the branches because they go to infinity and they go to negative infinity. It's easier to go to the left here. Just draw another branch. The next asymptote has to be another pi over 2 away, which would put it at the x-axis. And so that gives me 3 here, 0, -3, and then there's your 2 branches. So that's all we need at this point. All right, once you get that done, we're going to go to the one that just has the 2 graphs in the front. Okay, I got all kinds of stuff. Okay, we've done tangent, we've done cotangent, we've done sine, we've done cosine. Now we got to hit secant and cosecant. All right, don't write anything down yet when I go to the next slide. What's the first one on there? Cosecant. What is that related to? Which one is that related to? Sine. Okay, it's the flip of sine, right? So what you need to know is that you need to use the graph of sine to figure out cosecant. So you take a look here, there's the graph of sine. Cosecant is 1 over sine of theta. What aren't we allowed to divide by? 0. Where does the sine equal 0 at? Okay, it equals at 0. Where else? Pi and 2 pi. So what's going to happen when we divide by 0? If you think about the graph, we're going to get vertical asymptotes there. So at all of these points, we get vertical asymptotes. Now, what's going to happen between? So right now, just look at that part right there. When we take 1 divided by that, what's it going to look like? Okay, what's it going to look like? Well, think about what the values are. Right here in the middle, what is the y value there? 1. What's 1 divided by 1? It's 1. So at that point, the cosecant is going to have the same value. What happens at, say, a half? This has a y value of half. What's 1 divided by a half? 2. So that's going to be the graph there. And I also got a half here. It's going to be 2. What's going to happen as we get closer to 0, say 1/10. What's 1 divided by a 10th? 10. What's 1 divided by 100? 100. What's 1 divided by 1,000? It's going to be 1,000. So where's this going to go? It's going to go all the way up to infinity on both directions. Okay? Now, on your calculator, if you wanted to graph this, if I wanted to graph it, how would I graph it? Where's my cosecant button? Okay, I do 1 over sine. So I do 1 divided by sine. Now you watch whether you're in degrees or radians. I set this up so it would work. Sine of x. And if I hit graph, okay, that's what you're going to see. So in between the asymptotes is basically going to be an upside down parabola shape. Okay, so right here, that's going to go up. This is going to go down, but it's going to hit at that 1 or -1. And then this is going to go down for that. Now, all right, let's graph it. And let me do something here. Okay. Using the sine graph kind of as a guide, go ahead and draw in your asymptotes, which are going to be at -2 pi, -pi, 0, pi, and 2 pi. Now, the sine graph is not part of the cosecant. I just use it to help find it. But in that first, in between 0 and pi, okay, that one's going to open up. And once you got that, it alternates. Okay, it alternates. And let me go back to single page. And done? All right, thank you. And let's see, so here it's going to go to -1. Over here, we also have -1. And then in between negative pi and -2 pi, it'll be a +1. Whoops. All right, take a look at domain, take a look at range, take a look at period. All right, be careful on the period. Okay, be careful on the period. Because you're tempted to put pi, but somebody tell me why it's not pi. Okay. If it was pi, that means that there's nothing unique. It starts to repeat itself. So basically, if it was pi, then this would have to repeat itself in the top part the whole way over. Since it goes down below here, it doesn't repeat itself until it gets actually back to 0. So it's actually 2 pi is the period for this one. So 2 pi is the period. Domain, similar to tangent or cotangent. Okay, we got to word it that way. All real numbers except integer multiples of pi. And watch how you put the range. Avery, what do you think about the range?
It would be -infinity to -1 and then 1 to infinity.
Yep, and then it's going to include -1 and 1. So good. -1 to infinity, or is negative infinity to -1, union 1 to infinity for that. Period is 2 pi. Is it even or odd? You make sure you put that one down. I know I don't have it there. Even or odd? Look at the negative. Take a look at an angle and it's negative. Are they the same or are they the opposite? Look at pi over 2 and look at -pi over 2. Since they are opposite, this is an odd function. So that means that the cosecant, cosecant of negative theta is equal to the opposite of the cosecant of theta. Okay, for that. All right, now to find the secant graph, we need to use which graph? We need to use cosine. Same idea. Okay, same idea. So for secant, let me just do two of these. I'm not going to do the whole one yet on this. Where does it hit 0 at? It hits 0 at negative pi over 2, and it hits 0 at positive pi over 2 in there. It opens up. What's going to happen when I take 1 over cosine of theta? Then this is going to hit here, and then it's going to go up to infinity. Okay, so using this as a guide, go ahead and let's draw in our asymptotes. They're also going to occur at negative 3 pi over 2, negative pi over 2, pi over 2, and 3 pi over 2. So drawing your vertical asymptotes and then using cosine to tell you whether it opens up between the asymptotes or opens down. And so let me do this over here. I get negative pi over 2, positive pi over 2, and positive 3 pi over 2. Okay, now we just did the one in the middle, so it hits at 1. Whoops, hold on. And opens up. And now it's going to hit at negative 1 to the left. And also negative 1 at pi. All right, and let me do this. Single split. Okay, you just got to be careful here on the far ends. You have to go all the way to 2 pi. That is where it hits back at 1. Okay, so all the way to the right there, and then it opens up. And the same thing over here, all the way over at negative 2 pi, and then it opens up. Okay. So make sure it's all the way over there. You're only going to get that half a branch. Okay, for that. All right, so we've done sine, we've done cosine, we've done tangent, we've done cotangent, you've done secant, you've done cosecant. So you kind of got 2 things to do. I'm going to give you a little bit of time in class here. First thing is, on that sheet that has the 6 functions, this is going to be your kind of study guide. Put sine, put cosine, put tangent, and then I have it arranged cosecant, secant, and cotangent. So make those as neat as you can, as nice as you can, as accurate as you can. So that's going to kind of be your study guide. Because that's going to be the first question on the test. No calculator part of the test is to graph these 6 functions. So you have to do that. Oh, we didn't do period, domain, and range? Oops, let me do that. Let me go back. Where am I at? Page width. Thank you, Maggie. And period is 2 pi. Domain. All real numbers except odd multiples of pi over 2. Except odd multiples because it goes 1, 3, and it goes 5. Range is going to be the same as we just did for cosecant, negative infinity to negative 1, union 1 to infinity, including 1. This one's an even function. Okay, if you take a look at an angle and it's negative, they're going to have the same value, and we would write that as the secant of negative theta is equal to the secant of theta. Okay, for that. All right, now like I said, 2 things. First, 6 functions, take that as a study guide. I want you to upload that as well, because every now and then somebody just makes a mistake and maybe I can find it and correct it. And then these are graphing some of the tangent and cotangent functions. So that would be your second part. All right, see if you can at least get done with the graphs, or if you want to start with the book work, whatever you need.